Yowzers, it's another uptick in solar activity here, and that sunspot in the southeast is definitely the T-mass, or the most active sunspot. We'll cover it and lots more. We've got sunspots at a massive degree of latitudes, and we'll tell you all about it here at the Smash News Network, Least Busted Name in News. That's a 24-hour video from the SDO, the ever-popular 171 angstroms wavelength, just spectacular at showing the lower corona. And let's get even closer. Check it out. Just awesome imagery there from Solar Dynamics Observatory. So that has been the most active sunspot for the past 24 hours, and you can expect the solar flare watch to continue as a result of that quite large sunspot group. However, don't forget this group down here in the southwest. It is also magnetically complex and represents the other portion of the solar flare watch. You can also see that it's at a very low latitude there, not too far from the southern polar region. A feature of solar maximum is that sunspots occur at all active latitudes. This one up here is even higher. That's at about 40 degrees latitude there. That one is way up in the north. There you can see that forming, and that is indeed a sunspot there, just to the right of our Earth scale, right in here. You see that new sunspot group form. A feature of solar maximum is that you see sunspots at all active latitudes, whether it's at the equator or very high up near the polar regions. So, before I go on, here's the full disk view in that same wavelength. The house favorite, 171 angstroms. So we have seen a lot of sunspots degrade here since yesterday. We are actually expecting the sunspot number to dip slightly if things maintain on the course they are. However, if the sunspot number reached exactly where we forecasted yesterday, it would be in the 160s. So here you'll see a little bit of degradation and a little bit of growth. Overall, no major changes really happening there. Some new sunspots forming, some new sunspots evaporating, some right on the equator. Here is the SDO colorized magnetogram for the same day. That's today, February 5th, 2024. And let's take a look toward Earth for a brief moment here. Not our meteorology segment, volcanoes and earthquakes. So first, the volcano list. Abiko, Ibu, Semeru, Merapi produced another intense explosion with glowing lava bombs and so forth. Another interesting story is the Rupahu volcano. So a new heating episode there in the volcanic lake on the North Island of New Zealand. The color of the lake has changed from blue to green. The lake is cooler, or that green tinge is typically when the lake is cooler, to the more common gray color seen when warm. Also upwellings, sulfur slicks on the surface. The lake is also overflowing, which is a normal thing during the summer melt season. And the change in lake color is consistent with more gas flow, disturbing sediment at the base of the lake, which is now suspended in the lake water. So this indicates vents at the bottom of the lake are at least partially open, allowing hot gas and steam to drive the increase in lake temperature. So Rupahu, some activity happening there for sure, although not a lot of seismic activity, just some small clustered earthquakes. Also Popocatépetl, Santiaguido, Fuego, Nevado del Ruiz, Revenador, and Sabancaya producing eruptive behavior. Next, earthquakes. And we've got an earthquake watch for the west coast of the U.S. We'll tell you why in a minute. There are the past 90 days. And so check it out. The west coast of the U.S., we've got a quake down here at Baja California, one at Tijuana, one near Los Angeles, one near, northwest of Sacramento, and then one up here in the Cascadia fault zone. So a series of quakes there at the western portion of the North American continent, the North American plate boundary. So that's interesting. Again, the possibility of a large quake there on the west coast of the U.S., because any earthquake can be a foreshock. So these are the quakes of the 5 and greater magnitude for the past 24 hours. A 5.3 did strike Indonesia early this morning at 00:52. A 5.2 struck New Caledonia at 7:26. Japan had a 5.0 at 8:30. Reykjanes Ridge there in the Mid-Atlantic. The Mid-Atlantic Ridge there, featuring a 5.4, a 5.3. Indonesia had a 5.0, and then a 5.0 at Reykjanes. So those quakes all occurring between 1353 and 1439. Little global uptick there for a few hours. Also near the Volcano Islands, we had a 5.1. And that is where the quakes. Those are the quakes. Yeah, those are the quakes. And we're going to get to the radio flux and so on here in a moment. But first, let's look at some more solar imagery. So how about, there's 304 angstroms. Another classic SDO wavelength, the ionized helium spectra. Also note that huge filament there waving around in the northwestern limb, which is your upper right. That filament still hanging on, but swirling around and looking quite unstable. Also, plasma instability in the southwest and in the southeast. We'll get to some more stuff like that here momentarily. And let's talk about some stats. A 10.7 centimeter radio flux now at 173, so a big uptick in the radio flux. There's the one-year graph represented by the black line is the radio flux. The red line is the sunspot number, which again is now in the mid-160s. So there is the Space Weather Enthusiast dashboard forecasting by NOAA, showing a little bit of geomagnetic unrest likely tonight. So we could even see mild geomagnetic storm conditions. NOAA's forecast there is for the possibility of geomagnetic unrest or geomagnetic storm as a result of coronal hole high-speed streams or some transient CME impacts, coronal mass ejections. Next, Earth's magnetic moment from space for the past 4 hours, and we are having geomagnetically calm conditions here at the moment. We are seeing some variations in the solar wind, though, which we'll get to here momentarily. Today's a great example of how the ACE and Discover can show totally different data as they orbit the same gravitational equilibrium point, Lagrangian 1. Lagrangian point 1, located about 1 million miles in between Earth and Sun. A little bit of an uptick there in the magnetohydrodynamic pressure. Here's Earth's magnetic moment from the ground level, depicting magnetic flux density geospace delta B, changes to Earth's B field. So you can expect to see a little bit of an uptick in telluric currents here at the end. And of course, that is where you're most likely to see the aurorae. Right there at the end, a little bit of an uptick there, so good news for aurora chasers. KP index currently at 2. KP2 is the geomagnetically calm situation at the moment. There you go, KP2. Next, solar wind. So check it out. The ACE and Discover showing vastly different solar wind regimes here. The ACE currently registering about a half a proton per cubic centimeter, so a very diffuse solar wind density. Solar wind velocity here just under 440 kilometers per second. The Discover, very different. About 20 times as dense there, 18 times as dense for the solar wind density, and solar wind velocity here about 440. So same speed, but much denser there. An indication of the filamentary nature of solar plasma. GOES magnetometers are fairly smooth. The GOES magnetometers are located on the geosynchronous orbits, the near equatorial geosynchronous orbits of the GOES 16 and GOES 18. They are located at about 23,500 miles of altitude or so. And next we'll move to the top view ecliptic plane field plot. So, check it out. The South Pole current sheet, the South Pole magnetic sector here has grown massively just in the past several hours. So you see that red sector there. Watch, it's going to, fan way out. So that's interesting indeed. Let's stop it on the last frame there. So there you go. South Pole sector going to continue here for days, assuming nothing rapidly changes. And keep in mind, things can rapidly change when it comes to magnetic environments in space. So next is our line of sight field plot. Here the sun's B field is depicted in blue, solar polar fields in red and green for south and north, and of course the photosphere magnetism in grayscale. And look at all the organized magnetism on the Earth side of the solar disk. It's an exciting time to be doing space weather, and we're excited to have you watching. Next, coronal holes. Here's our line of sight coronal hole plot. And you can expect to see a bunch of South Pole-oriented coronal holes here. Check it out. Magnetic tug-of-war going on down there. So watch down here in the southeast. You're going to see a bunch of North Pole-oriented coronal holes just evaporate They're there, and whoops, now they're gone, as the South Pole magnetism is winning. So, as we forecasted throughout the cycle, you can expect an uptick in coronal holes, and there it is. Next, we'll show coronal holes from SDO. There's the 211 angstroms wavelength, which brings us to sunspots. So again, we are expecting a slight downtick in sunspot number between today and tomorrow. Let's take a look at some stats. Sunspot number here just over 160 at about, let's say, 163. 163 is a new sunspot number according to ROB, the Royal Observatory, Belgium. Now this new one up here, that is indeed a sunspot. We'll show you that later in the video before we get to our meteorology segment. That active region there is already a sunspot. Keep in mind this synoptic map was produced at 1430 Universal Time, so like 9 hours ago. Here's our solar flare monitor and scoreboard. And what's the next number? Next active region will be 3579, which should be this new group up here. 3579 at a very high latitude, as you can see. 10, 20, 30, about 41, 42 degrees latitude there. So lots of sunspots there, as many as 16 showing up in the past 24 hours. Next, we'll look at sunspots from SDO. There's the continuum plus 171 angstroms. Another 24-hour video from Solar Dynamics Observatory. There we've dropped the 171 angstroms. And so let's briefly sort of look at each one of these groups. This group up here, pretty stable. A new group formed up here. This group down here, pretty stable. These are pretty stable. These groups here are pretty stable. Pretty stable up here. A new group forms at this very high latitude, way up here. There it is. Looking stable, and looking pretty stable. So yeah, it might be a little uptick by tomorrow. I'm not sure. It might be about level. We don't have a lot of sunspots setting, so we're gonna have to see sunspots evaporate here in order for the sunspot number to drop. Let me change my forecast. We're expecting level to a slight uptick coming tomorrow, as there's at least one group that's risen over the eastern limb there, and another group that formed way up here. So sunspot number likely to increase mildly tomorrow. Next, let's look at solar flares and energetic particles, and that is a baseline proton flux. So no solar energetic particle events here at the moment, but the likelihood of seeing one is kind of high, as we have a major solar flare watch, both in the mainly in the southeastern limb, but also in the southwestern limb. Moving right along here to our GOES X-ray flux. Background X-ray flux is now at about, what is that, about a C2? About a C2 as far as the background flux. And the past 24 hours here, looks like 3 M-class flares. Let's take a look at flares from SDO. All right, so first is the 131 angstroms wavelength. Ah, yes. The hottest of the AIA wavelengths. 131 angstroms is great at depicting magnetic filaments, also active regions and solar flares. And of course, the area to watch remains that southeastern limb. That new sunspot is definitely an interesting one. So here's a close-up of that. A couple M-class flares on that video there. Just spectacular imagery once again from SDO. We'll switch to 94 angstroms next. Not too shabby. Once again, that is our T-mass, the most active sunspot of the past 24 hours. Also, don't forget this region that's reaching a setting mode down here in the southwest. It's also capable of producing large flares. Remember, folks, you don't need to have a large sunspot to see a large solar flare. And we'll also show that in 131 angstroms. So as it gets closer and closer to the limit, it does become statistically more likely to produce a large flare. And let's take a brief look at the sky overhead. As I want to know what's going on overhead, right? What about you? Well, if so, try skyandtelescope.org's star chart. It's splentacular, in my opinion. There you go, skyandtelescope.org. Just put in your location, click now, and you'll be able to see the currently brightest star in Earth's sky, Sirius. Over there in the southeastern, just above the horizon there, over the southeastern sky. In the constellation of Canis Major. Sirius, the dog star. And let's talk about the star that used to be the brightest star. Well, actually first, let's show a solar system forecast. So that's where things are today. That's where things will be in a week, 5 days until the new moon of February, my favorite phase. And let's talk about what used to be the brightest star. So this is the astronomy photo of the day, and this is the Carina Nebula. And back in the 1800s, the brightest star in the sky was Eta Carinae, which is, I believe, the largest star that we know of. It is very bright, very irregular, has lots of stellar spots, and is just a generally rowdy star. So, of course, massive emissions coming from that. And what you're looking at there is the Carina Nebula. The blue is oxygen, and the red and orange is hydrogen. apod.nasa.gov, if you want to check it out yourself. That's a pretty sweet image for your desktop, right? apod.nasa.gov, and let's move on to CMEs. And it's been pretty chill. Not too major. So there is today one significant CME there out of the southeast and another one out of the north-northeast. Let us know if you think those are earthly directed as we go to further analysis. Let's just skip ahead to the more zoomed-in view. There's LASCO C2 and C3. And we're going to let those play through. Let's let the C3 catch up here a little bit. There you go. Now the imagery on the left is a little bit ahead. So if you see a feature on the left, just shift your gaze over to the right, and you should be able to see the same feature. Now the SOHO spacecraft also orbits Lagrangian point 1. And there comes that CME out of the southeast rather, and then another less significant event there coming out of the north-northeast. And let's just skip on to our custom coronagraphs. There we go. Not bad, not bad. Another 24-hour video. That one may have earthly directed components, folks. So I'm going to say another CME on the way here. This one likely to arrive sometime late in the day on the 8th. Late day on the 8th of February, another CME impact. We are also expecting one tomorrow. See our previous daily space weather videos for details on that. Here's a slightly closer view, and you're going to see some plasma motions in this area down here. So I would suspect there may be some earthly directed ejecta. Earthly directed ejecta. There's an even closer view here. We've dropped the LASCO C3 and added 193 angstroms to the SDO imagery to add a little bit of contrast and detail to the corona, the sun's atmosphere. And here's the full equatorial zoom. And let's move on to plasma filaments. So plasma filaments are super important as they can turn into coronal mass ejections, and we've got quite a few in the Earth-facing portion of the solar disk, some very large and dense ones, especially in the northern region, but also a bunch there in the southeast, also in the southwest, northwest, so lots of filaments. That is the Cerro Tololo ground-based solar observatory featuring hydrogen alpha. And this filament down here is certainly worthy of a name. If you want to name filaments after living people, join us over on X, x.com/smashomash. Just follow the hashtag name that filament, and you can name filaments after your friends, your foes, or even yourself. Before we get to bonus features, we'll also show the latest from the Agose 16 SUVi. Couple features to note. First of all, this sunspot up here, which formed at a very high latitude, like I said before. This sunspot down here has got some plasma around it that looks unstable. Unstable plasma over here, and two massive filaments. Also, massive filament up here. So lots of features going on at the moment. And let's take a look at bonus features. So first, we've got the satellite charging hazards map. And we do see some minor surface charging there over the Middle East, the northern Indian Ocean, etc. A little bit of low-energy electrons there building up inside a spacecraft. Goes electron flux here in a sort of a low range there. That's the past 3 days. There's the 1-year graph. And the massive electron shortage ended. The longest electron shortage we had in a year. That's the 1-year chart from Solon.info with the relativistic electrons. Here's NOAA's forecast. And the last update was right on. So there you go. And NOAA is expecting a dip, and I would tend to agree because we have a couple of CME impacts likely to arrive at the Earth soon. Tomorrow and also on the 8th. So there you go. Next, we'll show the layer where it's measured. The F layer. Don't be effed. Realize that the F layer is at about 300 kilometers of altitude. Here it is in vibrational frequency. It's the bridge between Earth and space. This is the one that takes the most immediate effects from space weather. And nothing major going on in the F layer of the ionosphere. So pretty chill. We've had quite a shortage of space weather. The sun kind of is remaining a plasma miser. So plasma miser there, withholding plasma. As we expect cosmic ray flux to dip and dip and dip for another 18 to 20 months. There's the anomaly in megahertz from a 30-day median. And you may see some funky looking anomalies going on over here. That's the South Atlantic anomaly. It's pretty stable in that location. It's been there for years. The South Atlantic anomaly, folks, the weakest portion of Earth's magnetosphere. So nothing major going on there. Let's also show the global ionosphere nowcast, or WHAM, the whole atmosphere model. GPS users might benefit from viewing the left images. Radio operators might benefit from using the right images. Maximum usable frequency on the right, total electron content on the left. Total electron content depicts electrons to about 12,500 miles of altitude, which is the approximate altitude of your GPS satellites. We'll close out space weather with the latest. So there's that sunspot at extremely high latitude. Here's this sunspot, which is certainly the T-mass, the most active group. It is still beta gamma delta class, the most effective sunspot category of producing large solar flares. Last but not least, this group down here is certainly notable mention. It is also beta gamma class. Of course, it's so close to the limit, it's hard to say if it's delta class or not. I think it is beta gamma delta class. Yeah, that's beta gamma delta class. So yeah, solar flare watch continues, especially in the southwest and the southeast. So this is the #1 place to see a large flare for the next 24 hours, and this area is a close second. So anyway, let's move on to meteorology now that we've ended the space weather segment. So we're going to start out with the world's lowest pressure. Now I'm going to give you a clue here because we've zoomed in. Now, if that's low pressure, what can you guess from that map? You can see that it's rotating clockwise. So what does that tell you about it as a low pressure system? I'll give you a moment to type your comments. So yeah, why would it be a low-pressure system spinning clockwise? Isn't that what anticyclones or high-pressure zones do in the northern hemisphere? Well, that's exactly right, because that is clearly in the southern hemisphere. It is in the Southern Ocean, in fact. The world's lowest pressure is just off the coast of Antarctica. And the seas are actually pretty calm here at the moment, so not a lot of really strong low pressures on a global scale, but lots of high-pressure zones on the planet right now. Check out Siberia and Greenland and northeastern Canada. Also a huge anticyclone here in the northeastern Pacific with a pressure of 1033, a very, very high pressure. In fact, I think that's actually the highest pressure in the world. That's like Jupiter's red spot or something, folks. Check it out. Clockwise rotation, high pressure zone. Did you know Jupiter's red spot is not a storm in the sense that you would call a thing a storm on the Earth? Yeah, Jupiter's red spot, it's an anticyclone. It's a high pressure zone where there's a pressure downward on the planet. So anyway, that's what's going on. And let's move on to clouds and fog over the Americas. So we also do have a very strong low pressure system about to form here off the coast of Florida. It's already forming right on Florida. You can see that counterclockwise rotation happening there in the Australia of the U.S., Florida. So that's going to move off the Atlantic coast of Florida and actually strengthen and become an even stronger storm. It's going to produce some high surf for South Carolina. Great example there of a low pressure zone forming. And let's move on to our windy.com map depicting temperature. There's what's going on for temperature. We actually have some anomalously warm temperatures in Canada, which we'll get to here in a moment. First, our weather.gov map there is weather.gov, the National Weather Service homepage. If your location is lit, just click it. Those are a little bit too many counties for us to cover, but we got lots of warnings here. The main ones are flooding for California. An additional 5 inches of rain are on the way. So be aware of that. Also some winter storm warnings for large portions of the country. Here comes some forecasts, starting out with the temperature anomaly forecast. So check it out, all this warm air in northern Canada. Look at it. Look at how ridiculously warm it is up here. Dag. That's like over 20 degrees Celsius above normal. That's a 72-hour GFS temperature anomaly forecast. Very warm temperatures there for the next 3 days. North central U.S., but especially northeastern Canada. Very, very warm. Next, our jet stream, and this is part of what's making the weird weather patterns as well. The jet stream is very, very far south right now. You can see it's going across Mexico and making its way into Texas and so forth over the next couple of days. It's going to start to normalize there after about 3 days. That's a GFS 72-hour jet stream forecast, the 250 millibar winds. Next, our total accumulated precipitation forecast in inches, the same model, the GFS 72-hour. And look at the rains in California there. That is an additional 4+ inches of rain coming to Southern California. So that's a thing. And they might need rain. They don't need that much rain. If you've ever seen a mountain collapse, rains like that cause mountains to collapse. That is suboptimal. Don't get caught under a collapsing mountain, folks. Next, our accumulated positive snow depth change in inches. Quite a bit of snow there. Showing up especially west of the Rockies. 72-hour GFS positive snow depth change forecast in inches. Last but not least, pressure and precipitation. The same model, GFS 72-hour. And you see that low form off of Florida and then rapidly break up, but it will produce some big wave pulses. Shout out to all my Carolinian surfers who don wetsuits and go surfing regardless of whether it's cold. Shout out. Next, lightning. That's the past like 10 hours. And let's show the last hour of lightning strikes from lightningmaps.org, your real-time lightning map powered by blitzachtung.org. And we ain't got no terrestrial strikes, but there is some lightning there in the western Atlantic. On a global scale, pretty mild here, only about 100 strikes per minute. We'll close out the video with the U.S. Doppler radar map, starting out with this close-up of L.A. L.A. getting kaplastered with rain as pulse after pulse comes through. Long Beach seeing some heavy rain now, and L.A. proper, also Santa Clarita, etc., as the Pacific pipes in more and more moisture. We'll briefly zoom out to show the full 50-state view before we focus on the lower 48 view. So that's where things are now. That is vertical motion in the air column detected by ground-based Doppler radar systems. Here's a space-based system, 3.9 micrometer infrared radiation shortwave, showing clouds and fog. And here is the water vapor map. You can see those effects of the jet stream, some very funky weather patterns here, and it's got to do with the warm air in Canada and the jet stream being so far south. Here's your recap. And consumer tip: when your Doppler is unclear, try the water vapor map. If you understand atmospheric physics, you'll be able to impress your friends and foes by forecasting the weather. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.